Hello students, today I am going to start new chapter, that is chapter number 3, classification of elements and periodicity in properties. At first we discuss about the need for classification of elements. As we know, in the beginning of 18th century only few elements were discovered. So it was quite easy for scientists to understand or study their properties individually. But as the more and more number of elements were discovered, and it was very difficult for scientists to study their properties individually. As we know, in 1800 only 31 elements were known, but in 1865 it becomes 63, and nowadays 118 elements were discovered. So it large number of elements and their study, how it will be possible. So scientists thought about any systematic way to study of this elements systematically or their property individually. So after numerous attempts ultimately they successful to found the way in which the properties of element having similar properties grouped together and different elements with different properties separated out. So see here. So at first, what is classification of elements? What is classification of elements? The arrangement of elements, simple. The arrangement of elements in such a way that the similar elements fall within same vertical group, and the dissimilar element are separated. So the classification of element lead to the formation of periodic table. What is periodic table? So write down the periodic table. Periodic table may be defined as the table which classify the element in such a way that elements having similar property are grouped together. In the same vertical column. And dissimilar elements are separated from one column or one another or one another. In this way we can define periodic table, or we can also define in another way also, or we can say that periodic table may be defined as the table giving the arrangement of all the known elements according to their properties, so that similar elements fall within the same vertical column and these similar elements are separated. So what is periodic table? We can define in this form also. Periodic table may be defined as the table giving arrangement of all the known elements according to their properties, so that similar elements fall within the same vertical column and dissimilar elements are separated. So in this chapter we will discuss the historical development of the periodic table, Mendel's periodic law and Mendel's periodic table, modern periodic law, and classification of elements into S, P, D and F block and their property. So at first we will discuss the historical development of the periodic table. At first we talk about the historical development of the periodic table. First scientist named Lavoisier. Lavoisier's classification. Lavoisier divided the known element into two groups. He divided the known element into two groups, that is metal and non-metal. Metal and non-metal. On the basis of physical property, metal is hard, non-metal is soft, metals have high melting point, non-metals have low melting and boiling point, so on. So his basis for the classification was on the basis of metals and non-metals. And further drawbacks of this scientist Lavoisier, further his classification was rejected after the discovery of metalloids. Metalloids. After the discovery of metalloids, the classification of Lavoisier was rejected, and the next scientist named Dobbernius, he came with the triads. He make a group of 3 elements known as triads. The next attempt was by Dobbernius. Dobbernius triads. Triads means group of 3 elements. He arranged the element in a group of 3 elements. Group of 3 elements such that the atomic mass of middle element is the approximate average of the atomic masses of the 2 terminal elements. 2 terminal elements. For example, lithium, sodium and potassium. The mass of lithium, atomic mass of lithium is 7, the atomic mass of sodium is 23 and the mass of potassium is 39. And when 7 plus 39 divided by 2, it comes 23. So he makes a group of 3 elements and said that atomic mass of middle element, the approximate average of the atomic mass of these 2 terminal elements. He make 3 triads: chlorine, bromine and iodine. The mass of chlorine 35.5 and the mass of bromine is 80 and the atomic mass of iodine is 127. According to Dobbernius, when 35.5 plus 127 gives the value 81.25. Approximate average the atomic mass of the 2 terminal element. He make one of the triad also. Calcium, strontium and barium. The mass of calcium is 40, strontium 88 and the mass of barium is 137. So 40 plus 137 gives the value 88.5. And what was the drawbacks of Dobbernius triad? Why his theory was rejected? It could not, he could form limited triads. We can write in this form also. He could form limited triads. All known elements could not be arranged in such tracts. Next attempt was by Newland's. Newland's law of octave. According to Newland's, if element are arranged in increasing order, of their atomic mass, then the every eighth element has properties similar to the first element. For example, just like music notes, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, then potassium, then calcium. Just like music notes, sa, re, ga, ma, pa, dha, ni, and it becomes sa. So just like music note, every eighth element repeated the property of first element. So it was the Newland's law of octaves. And drawbacks of Newland's, write down the drawbacks also. He could arrange element up to calcium only. Next, Lothar-Meyer classification. Lothar-Meyer classification. Lothar-Meyer arranged the element on the basis of graph. He make a graph, a plot, atomic volume, versus atomic weight. So suppose graph comes like this and this, so on. The actual graph was very difficult to draw, so just I am drawing to explain. So write down the observation. A curve was plotted between atomic volume and atomic weight. Elements with similar property occupied similar position on the curve. Suppose alkali metals, all peaks are occupied by alkali metals: lithium, sodium, potassium and rubidium. And this descending curve, they are occupied alkaline earth metals. So on, write down the all points. So in the graph, all alkali metal present on the peak position and same position occupied. Similarly, halogen occupied ascending position of the curve and alkaline earth metal descending position of the curve and metalloids and transition element and transition elements. Bottom part of the curve. And what are the drawbacks of low thermia? So write down the drawbacks also. Practically, it is not possible to remember position of the all elements. Practically, it is not possible to remember position of the all elements. Now, next, Mendeleev comes to classify the known elements